Assalamu alaikum. Today the topic for our discussion is data science in medical research using R and Python in inferential statistics. As in previous lectures we have discussed about descriptive statistics. In this lecture we will talk about inferential statistics, that's how R and Python is used for inferential statistics. But before that we will talk about how to collect datasets from Kaggle. First of all, we have to enter the name of the website Kaggle in a Google. Then here, this is the website. If we click this, we will enter this website and this page will come. Here we will enter on the datasets, and in datasets, then in the search bar, we can search whatever dataset we want to research on. For example, I have entered the diabetes dataset in the search, and here the diabetes dataset is given to me. Now this is the diabetes dataset. From here we can see this one. This one is used to see the diabetic dataset or whichever dataset you want to see. And the next option is for download, to download this dataset in CSV file. So this is about Kaggle dataset. And after this, how will we upload this dataset into R? So first in R, we will install a package called read Excel. After installing it, I think it is installed. So after installing it, we will just load it. So now it's load. Then we will go to the files. Here we will go to import data. From here we will go to from Excel. Now you will see this file. Here we will browse for the file which we want to upload. The data which I want to upload is here. So now this data set will load into the R, and then we will click on import to import it. Now the data set is imported in the R, as you can see here. This is the data set which we downloaded from Kaggle and then upload into the R. After this, we will go to our session to start on inferential statistics. So the learning objectives of this session is understand the principles of inferential statistics and its role in medical research. Differentiate between descriptive and inferential statistics. Conduct hypothesis testing like t-test, chi-square test, ANOVA test using R and Python. Perform regression analysis to predict medical outcomes. Interpret statistical results and apply them to clinical decisions. These are our learning objectives for today's session. Now the introduction of inferential statistics is that inferential statistics is a branch of statistics that allow researchers to draw conclusions about a population based on data collected from a sample. Unlike descriptive statistics, which summarize data like mean, median, standard deviation, variance, inferential statistics help us make predictions, test hypotheses, and generalize findings beyond an immediate data. In medical research, inferential statistics is crucial for determining whether a new drug is effective or not. If there is a significant association between a factor and a disease, the risk factors that predict disease such as diabetes or heart disease. The importance of inferential statistics in medical research. Inferential statistics is vital in evidence-based medicine because generalization to population, decision-making in medicine, testing hypotheses in clinical research, reducing medical uncertainty, and determining causal relationship. Like in generalization to the population, inferential statistics allow researchers to make valid conclusions about large population from limited data. Clinical trials are conducted on samples of patients, but results are applied to millions of people. Now, in decision making in medicine, inferential statistics help doctors and policymakers decide if a treatment should be approved, continued, or stopped based on statistical evidence. Testing hypotheses in clinical research. Researchers use inferential tests to determine whether a new treatment, drug, or diagnostic test is statistically better than existing methods or not. Reducing medical uncertainties. Medicine involves uncertainties, but statistical inference helps quantify the likelihood that an observed effect is real and not due to chance. Determining causal relationships. Statistical models help identify risk factors from diseases and guide preventive measures. Now, key concepts in inferential statistics. These are some of the key concepts in inferential statistics, like population and sample. Population is the entire group being studied, and sample is a subset of that population which is used for the study. Inferential statistics allow us to generalize results from a sample to the population. Like sample is a subset of a population, and we use the statistics to apply the results of the sample on the population. Now, hypothesis testing. Hypothesis is a statement that is tested using statistical methods. Null hypothesis is there is no effect or no difference between the factor in a disease. Alternative hypothesis, there is an effect or difference between the factors and disease. Statistical tests help determine whether to reject or fail to reject hypothesis, null hypothesis. And the third one is statistical significance. The p-value measures the strength of evidence against null hypothesis. If p-value is less than 0.05, the test is statistically significant, like we reject null hypothesis. And if the p-value is greater than 0.05, the result is not statistically significant. The fourth key concept is confidence interval. Confidence interval gives us a range where the true effect is likely to lie. Introduction to R in Python for inferential statistics. Inferential statistics requires specialized tool to analyze medical data efficiently. Like before Python and R, there were many tools. SPSS, you have heard the name of SPSS and Stata. Now the most advanced tools are R and Python, which are widely used programming languages in medical research and biostatistics because they offer powerful statistical capabilities, data visualization, and reproducibility. R is excellent for statistical analysis. Packages used for inferential statistics in R are tidyverse, ggplot2, infer, and three others. Similarly, Python uses the libraries of pandas, NumPy, Skippy state models, and CPA. Now we will come to inferential statistics in R. Basic summary functions in R are t-test. The purpose of the t-test is to compare means between two groups. ANOVA test is used to compare means between multiple groups. Like t-test is used for only two groups, but ANOVA compare the means across multiple groups. Chi-square test, it is a test for association between categorical variables. Correlation measures the association between two numerical variables. In regression analysis, examine the relationship between a dependent and one or more independent variables. These are the basic codes for R. like t-test is a code of t-test, and y is one variable, x is another variable, and data, whichever data we want to test, we will enter it here. Now this is the ANOVA test, which is used for comparing mean of different multiple variables, then chi-square test, correlation and regression analysis. Then we will discuss it one by one. Like in this is the test, the code for t-test. Like you can see here, t-test data. Then what is the data frame? Data frame is this. These two are groups. This is the data. This is not the t-test. This is the data, and we will use this data here in the code to print the results. Now this is the t-test code. So there are two groups, score and group. So score is the one categorical, score is the one variable, group is the second, and then the data is t-test data, which is mentioned here. So if we run this test and view the test, it will show us these results. This is the results of the t-test. And if we print the results, it will give the results here. So now this is the data and test for ANOVA. You can see here in the Zoom version that this one is the data. It is also given in the Word file. This is a dummy data. So ANOVA test AOV, and then these two are the variables, and then data is ANOVA data, which is mentioned here. This is the data. So the data is ANOVA data. And now this test is applied in this variable, so we will print this variable here and view this variable. If we view this variable, the data and the results will come here, and if we print it, then the results will come here below. Okay, now this is the data and test for chi-square in R. This is the chi data, similar to the other chi data. Then the chi-square test. This is one of the variable in chi data. Chi data and this disease is the variable. This show us that this disease belongs to this variable. Disease variable belongs to chi data. And similarly here smoking variable belongs to chi data. Then we view the results as in the previous test and print it. So the results come below and above here. Now this is the test for correlation, which show us the association between two variables. So this is the data for correlation test, and this is the code. So correlation test, this variable belongs to correlation data, which is here, and this variable also belongs to correlation data, which is mentioned here. And the method we want to use is Pearson method. And there is another method which will be discussed in coming slides. Then we view the test results and print it. So the print result, the view result come here, and the print results are below. Okay, now this is the test tool like the previous, but here the method is changed to Spearman method, and then the results come here. Like you can see the p-value in the above results. The p-value is 0.101063. Similarly, these are the other parameters. Okay, now this is the last test, regression analysis. And in regression analysis, the data is regression data. This is the code for the data, also given in the Word file. And this is the test with this variable. Actually, I used this variable to keep it simple. It helps us to view it and then print it. If we give this code directly, it will give us the results. But this one, like making the code as a variable, it helps us to choose whichever version we want to see, like as in the print version we want to see or in the view version we want to see. Okay, now these are the basic codes for Python, like t-test underscore indxy, and this is for the ANOVA test, chi-square test, chi2 contingency tables, correlation and regression analysis. We will now use these data. Okay, in the Python, first of all, we have to import the libraries through which we will do the stats. Like import numpy, import pandas, pd, import skippy stats, and import from skippy stats, import t-test underscore ind. This means that skippy stats is a library, but only we want a t-test. Therefore, from skippy stats, we import only t-test. So here, this is the data in Python, t-test data. This is one group, this is the second group, like group and score. Then here is a test for the data, like t treatment, score, control score, and then t test is here. Okay, now the treatment score, t test data, group, and then treatment in group score. Then here the control scores, t-test data in group. Here these both are similar. And then treatment and control. Here in these two, we have to give these two codes, because first of all we have to specify the treatment and control in the group and score. So in the treatment and then in the controls, we have to specify the group and score for the variables. Then here is the test. So the t-stats is, this is the variable and this is the main test, t-test.ind. Okay, we will see it here. t-test dot underscore ind, treatment score and control score. Between these two variables, score and score, between treatment and control, we use this test between the scores of treatment and controls. So the results is as follow: print t-test. So the results will be given. P-value is 0.1524. You can see here. Other value is this. Now this is for the ANOVA test. Here is the ANOVA test. Similar the Skippy stats. We will import F1 data from Skippy stats for ANOVA test. NumPy as NP pandas PD similar to the t-test. Now this is the data for the ANOVA. This is ANOVA data, like there are many variables in this. In the Python, in the R, there is no need to verify or clear the variables, but here, as we can see that A, B, C, capital A, B, C are given here. But here again, we clear it to the Python that this is our data in group as A and score in these two variables, and then these data we will specify. So we will specify these data here in a simple codes for the Python, and then we will run the test in this way, that ANOVA stats F1 way. Then we do not use capital ABC, we used A, B, and C, like these data which we have cleared to the Python. And again print ANOVA test, and below are the results. for the ANOVA test. Similarly, this is the chi-square test. Skippy states we will import chi-square contingency. This is the data. Here we will create contingency tables. Like we will create contingency tables from this data. So contingency tables, the code for contingency table is pd.cross tabs and then smoking from chi data and disease. This is the disease variable from chi data. So the contingency table, this is the variable. Now chi states we will apply the chi-square test, and the chi-square test is chi2 underscore contingency and contingency table. So if we print the value will come, the p-value will come here as 0.88 and the expected frequency observe data that will come in the results. Now this is correlation analysis. Again, we will import Skippy states, and in Skippy states Pearson or Spearman. Both are used in the correlation analysis. This is again the data for correlation data. Study hour and exam score are the variables. Now the test for correlation is we use the Pearson method. So Pearson will be in first. In R it is in the last, but here in Python it is in the first place. So Pearson, then we will go to data and variable, data and variable. So it will give us, if we print the correlation variable, mean that correlation test, it will give us the results as follows. Now this is the regression analysis test. We will import AP, state models AP as SM. This library is used for regression analysis. This is not Skippy States or NumPy Panda. This is another library which is only used for regression analysis. So this is the data for regression data. A regression analysis, one variable, second variable. This is the data frame. Now here we will specify the variables as x, y, like x is the regression data in age, y is salary in the regression data. And then we will use the constant like the dependent and independent variable. So the constant is independent variable and the another is dependent variable. So we will make one of these two variables are data a constant to show to give a prompt to the Python that one of the variable is constant and that is x. So in the regression test, if we use the formula sm.ols into the dependent variable will be first and the constant will be second, and then dot fit, and then the code will be applied, and if we print the results it will occur below. Okay, these were the test analysis and codes applied. Now if you want these results, the Python results in table form, like you have seen here, none of the results is in table form. It is in a line. This one is again in a line, and the previous one was also in a line. So if you want to print these results in a table form in Python, first the data will be converted into table format. Then use tabulate library. This is the library to make a table for the results, to create a table for the results. An example is shown in the below slide. So this is the slide, like these are the results for T states or T test. Then now what will we do? We will, first of all, we will get the results like p-value. Here is the p-value, you can see. Here is the df. So here is the df. I specified these three values to the Python, that t statistics are t statistics dot statistics. Now the p-value is t stats dot p-value. It means that this p-value are in these results, t stats. This is the variable and this variable has these results. So the p-value is in the t stats. So df is this. And now table. Now we will make this data into a table format. So this is the table data, and the table data t statistics, p-value, degree of freedom like df, t stats, p-value. Okay, now we will apply this tabulate format to make this data in a table format. We will use tabulate library, and then we will use the formula for it, like table data. These three are data for it, like t stats from this results, p value from this results, degree of freedom is df from this results. And if then we print this code as given here in a grid format, we tell it that I want the table in matrix values like these two. These are the results, and I need values and parameters like matrix, and I want the table format as a grid format. So it has given us the table format, and the t statistics is this p value, and degree of freedom is 28. Actually, this slide is only for the simplicity. If we take the results from this only one line, it is very difficult. Not very difficult, but we have to look inside into the line. But if we convert it into a table, then it is very easy to get the results. Conclusion. Now we have entered into a conclusion. Inferential statistics in R provides powerful tools for analyzing data, testing hypotheses, making predictions, using the appropriate tests based on data type and assumption, ensures valid and meaningful results. Thank you.